I'm Scott L. Miller, and welcome to another Sam IT. And in today's episode, I want to talk about the incredible challenge that we have as people who work in IT and working in computers, that the rapid change of pace is so much that it's nearly impossible to keep up. Everyone talks about it, right? If you started your career in the early 1990s, you will have had to have reinvented yourself time and time again, learned entirely new technologies, rethought how you think about everything you do in the industry, constantly learn completely new skills, apply everything new, and throw everything away that you've done in the past. Except everything I just said, while repeated by everyone all the time, is completely and utterly false. IT does not change that quickly. This is something that people have been repeating for decades, and it does come from a real place. In the 1940s, 1950s, 1960s, computers were a very new thing. They were just figuring out vacuum tubes and digital technology and programming, and all of these things were absolutely brand new. They had never been able to do them with machines or with electronics before. The introduction of the transistor and then the microchip really did create some pretty big changes, and in the 1960s, they started to develop the concept of networking. But it is really important to understand that almost every concept that we know today was fundamentally developed and well understood by the end of the 1960s. It was applied throughout the 1970s and came to fruition, and by the early 1980s, nearly everything that we know today, everything that we have today, was already created, well understood, documented, and being taught even at an elementary school level, and very few really significant changes have come about since that time. Of course, some things do change. And what people are often referring to when they reference rapid pace of change is that new products are coming out on the market all the time, and that they have to be aware of a faster processor or which socket a processor goes into. Really simple things that don't really require any amount of training. You just read them off of a spec sheet. If we were to compare it to something like automotive technician, an automotive technician is unlikely to say, oh, the cars change so quickly, I have to learn all new things all the time just because a new model comes out. A 2021 Corolla and a 2022 Corolla are going to have some different parts. They're going to have to look in the manual and see what the changes are. They're going to have to possibly get a new tool or order a different part for something. Yes, but that's not a relearning. They don't have to go back to school. They don't have to have a professor explain how the new, slightly different engine is going to work. No, they look at a spec sheet and go, oh, I get it, and they move on. It takes them a few minutes and maybe exposure to it one time. You don't worry that bringing your brand new Corolla to your mechanic who was working on your old Corolla yesterday is going to somehow blow him away and he's not going to be able to handle it anymore. You don't select your mechanic because he knows that one specific car. Once in a while, you get a mechanic who specializes in, say, foreign German sports cars, but they can work on a lot of different things, and even then you could bring him your Corolla and he'd be okay. IT is like this. We do need to know that Windows 22 has these differences from 2019, or that Ubuntu 2204 Linux is different from 2110 in this way. And we need to understand where vendors are going and what their pricing and licensing structure is, and those things change, but they change in a way we simply looked it up in the past, saw what it was, and we look it up in the future and see what it is. Vendors changing the names, model numbers, or very small variations in products is not a relearning process, no matter what anyone wants to tell you. Does it require constant education? Of course it does. Every worthwhile career is going to require constant updates. If it didn't, the value of those fields would be incredibly low. Compare it to a medical doctor. A medical doctor is not working on humans that are fundamentally different from year to year or generation to generation. A doctor from 100 years ago is working on the same patients that they are today, by and large. What is different is a constant update in medicines, but that is a very small change year to year. Whether you are a new doctor or you've been a doctor for a long time, you still need to know the names of current medicines, what those medicines do, the current best practices around them, new findings and such, but it is a small amount every year. You don't have a new finding come out and suddenly all the doctors who've been out there no longer be able to practice medicine because a new thing about aspirin has come out. It's not like that, and IT is the same. Just because Intel brings out a new, faster chip, even a completely new chip architecture, doesn't really affect very much. In the recent history we had spent the last 20 or 30 years, depending where you are, focused on PC technology as the absolute foundation for everything we did. It was a foregone conclusion that Windows came out only for PC architecture, also known as Intel 32 and then AMD 64, depending on the generation that you're looking at. That Windows came out only for that. I understand it didn't exactly come out only for that, but that's a different discussion. For decades was no big deal because everyone just assumed that's the architecture they'd be using. But it wasn't the architecture we had when I got into IT. And in the last 2 years, two major products have completely shifted the industry. Well, three major products in reality. The Mac computers, the Raspberry Pi, and Chromebooks, all of which either are ARM-based instead of AMD 64 or optionally ARM-based and are the best-selling categories of computers, have fundamentally changed that AMD 64 is no longer a foregone conclusion and in fact is kind of a backrunner when it comes to desktop and mobile computing. And yet, nobody had to relearn anything. That was as simple as saying, hey, there's a new architecture out that is now more dominant than AMD 64. You should have known things about computing architectures prior to that. There's all you need to know is what the name of this new one is, and then to be really useful, how is its performance characteristics different than AMD 64? That's about it. When I got into IT really heavily, there were about 5 dominant architectures. These 5 were everywhere. Some of them were like SPARC and MIPS, and shortly after I got in, Itanium, that one was not around when I first got in. There were Alpha and others. There were lots of different architectures competing with Intel 32 and the Motorola families like the M68000 and the M88000. There was this brief moment in history where the Intel family, the Intel 32, IA32, took over as the dominant architecture. Intel themselves didn't see that as being as dominant as it was, and they thought IA64, the Itanium family, would replace it in time. They were wrong. AMD said, no, we think it's actually stronger than you think it is, and extended it to the AMD 64 architecture, which is actually a new architecture, just backwards compatible. And they managed to hold on for about 25 years, totally dominating the market. But that was a flash in the pan, and anyone who knew how architectures worked in general, knew any history, saw it that way, and are not in any way surprised or caught on the back foot or needing to adapt in any way to the fact that ARM, which is from the 1980s, is now more popular. We only are seeing a change in popularity, not a new technology, not something that you need to relearn. All you need to know is that the architecture has changed and which products are available on which architectures and which architectures do people want to buy. This is not complicated. Even the most dramatic things that we've had happen in the last 25 years, such as the universal adoption of the internet protocol and connection to the internet, cloud computing, and containerization, none of these things are actually all that new. We had the internet and the internet protocol starting in the late 1960s. We had plenty of time to get ready for it, even as an individual product. We're not even talking about networking in general. Cloud computing is really just a way of delivering products we already had. Not that it isn't a brilliant technology, and not that Amazon doesn't deserve incredible kudos for bringing it to the forefront and making it an important part of our everyday routines, but they only packaged and brought forward some technologies we should have already known and put them in such a way that we wanted to use them more often than before. Containerization has been around since the early 1980s, and while incredibly important and powerful, it's just, again, more repackaging of the same old things. That doesn't make it bad. That doesn't mean you don't want to use it a lot of the time. I'm not trying to downplay those quote-unquote new technologies. I'm simply pointing out that if you took these technologies and introduced them to someone in 1972, they would pretty much go, yeah, given the obvious increases in CPU power, RAM capacity, storage capacity that we've been anticipating since we first invented computers, these are all things that we logically would see as being the final conclusion. This is where we really realize there is no change. Should we go back in history, and we can actually do this in a lot of cases, we can see that these things were already expected long ago. So if we go back to the 1970s, basically everything that we use today was already in use then. Most of our programming paradigms, many of our programming tools, the major languages or language families at least that we use were already in place. The language paradigms were in place. Concepts around how to write software projects, our networking Not just networking as a general concept, but the networking we have today was already in place. In the interim, lots of other networking protocols vied for supremacy and ended up losing, but we didn't know that at the time. At the time, we knew somebody was going to win that race, but we didn't know who it was. Today, we can look back and say, oh, yeah, it makes sense that this is who won. And if you went back and told people from the 1960s this technology is going to be the dominant one for decades, they would say, wow, that's unexpected, but we can see why it's possible. We're not looking at major shifts in technology, just in utilization. The same kind of thing could happen with cars today. Today, Toyota is the largest maker of cars, but it's not out of the question to imagine a Volkswagen or a Ford suddenly having a process to make their cars 5% cheaper or 10% more reliable, things we would not see as a shift in any way in the market, but it would be just enough to switch who's the dominant car maker for a decade. Right? We would not say, oh, cars change so much. We would just see a slight shift in form factor, like we saw SUVs become more popular when gas became less expensive, things like that. That's what we see in technology for the most part. All of these things were already well understood way in the past. In the early 1980s, there was a show, and I've talked about it here on this show in the past. Bits and Bytes was produced for Canadian public television and provided to American public television in the early 80s, meant for elementary school kids to learn about computers. At that time, they taught the computers that were currently on the market: Commodore 64, Apple II, Trash 80, TI, and those types of machines. Right? So very, very old things that if you looked at them today, you'd say, that's nothing like our computers that we have today. And yet, they are. They had operating systems, they had multi-user support, or optionally did. They had graphical user interfaces. They had the mouse, they had touchpads, they had trackballs. They even had networking on those old devices. Of course, everything was really slow, and that's the main limitation. Had those devices been much faster, we would be basically where we are today. Almost everything that has changed is simply based on everything being faster, or the storage being bigger, or the memory capacity being larger. Screens have advanced more than the computers have in many cases. I don't want to downplay the amazing engineering that has gone into making computers able to do what they do today so fast and efficiently. But these are predicted things. There have been prediction laws that have been going on forever. Moore's law, for example, has predicted most of the advancements in CPU performance. So going back decades, we had a really good idea of not just how fast computers would become, but when they would have gotten there. And those predictions ended up being accurate. If you watch Bits and Bytes and you watch associated shows such as Compute Magazine and so that were on TV at the time, you can go back, you can find them on YouTube today, or at least you could a number of years ago when I looked. You're able to go on and watch them talk about the technologies of the day, and they would give a very good understanding of what we had in 1983, 1984. And those technologies are surprisingly advanced by what we remember the standards to be. We look back and think about things like the Atari 2600 and think, wow, computers were all but useless back then. That's not the case. They had spreadsheets, they had word processing, they had many of the things that we worry about today. And the big limitations were things like backups and hard drives and cost. All things that they knew they were going to be able to tackle. But when they talked about the future, when they told children, school children, at my age, right, 7, 8 years old in the early 1980s, talking to us about what the future of computers was going to be, they generally accurately predicted what computers were going to be like today. And by that time, almost all of the technologies we use today, virtualization, containerization, networking, security, multi-user operating systems, all of those things were already in place. Most of the operating systems that we use today, such as BSD and Linux, were already either their backgrounds were being created because they were based on Unix, or things that were going to use them were starting to exist. So even Windows, which was DOS-based in its original days, yes, DOS was not around quite at the time that they made that, but CP/M that it was based on was. Older versions of things, names had not come out yet. Later, open source rewrites had not come. Windows NT was an OS2 remake of DOS. Yes, we have rewritten things, we've started over, but the families of the operating systems were already in place back then. We haven't really reinvented things. The biggest change was macOS that came out in 1984. That was a completely new operating system that was really important for a long time, but even it fell by the wayside like so many flashes in the pan, and they ended up reverting to a BSD-based system, which already was starting to exist in code in 1983. There isn't that much that has changed. and it's mostly vendor stuff. This is important to understand both as IT professionals and as businesses. Our expectations of ourselves and of our IT departments need to accommodate the fact that there is a huge continuous need for continuous education around vendors and products, expectations, security, current trends, paradigms. Those things need to be kept up on, and that takes a certain amount of time and effort, and we need to expect people to do it, and we need to give them the resources to be successful at doing so. That is absolutely true. IT is a tough field and requires continuous education. But because of those things, we tend to have one of two things. Either companies have no understanding that there is a need for education. They think by taking one class in IT, magically you will know everything and you have no need to keep learning. That means your team is never going to keep up and never have gotten up to speed in the first place. And then the other camp thinks that it's so hard that they constantly have to bring in specialists and that IT is magic and constantly changing and reinventing itself every year. And there's no way for their staff to have any idea what's actually going on, and they don't trust them, and they expect vendors to tell them everything. Both of these things are crazy. In the middle ground is where the healthy IT departments are. They understand that there is a lot of things we have to learn year to year, but they also understand that getting a solid foundation in the basics means that keeping up is something that people can do. When you hear people say things like, how am I expected to know all these different things about IT? Nobody could learn all these things. Chances are what they're talking about is trying to memorize what all the different vendors are doing and how their products work together without understanding how anything works. Because while IT is a very large field and a very complex one, it actually isn't that insurmountable to understand enough to be able to work in nearly any aspect of the field, carry on a conversation about nearly any part of it, and be useful. Sure, you're not going to learn every product, but just like we say with, say, Linux and Windows systems administration, if you actually know how to run Windows, running Linux takes no effort whatsoever. And if you already know how to run Linux, running Windows takes no effort whatsoever. Of course, there are licensing differences, command name differences, different approaches to certain things. Sometimes you use a GUI and sometimes you use a command line. Whatever, there are differences, but those differences are not conceptual differences. Those differences are vendor level things. This is the tool we use. This is the name we use. Whatever. That Windows refers to logical volume management as dynamic disks, and the Linux world refers to them as logical volumes. Takes this long. All I had to do was say that statement, and if you know dynamic disks or logical volumes, you now know everything you need to know about the opposite one to make all of your decisions about it. It explains everything in that one, here's the term we each use for the same thing. Now, which tool do you use to manipulate that? Sure, that takes a little bit of time to learn, but not very much. If you're on Windows and you want to learn Linux, you simply look up what commands allow you to do that, or what graphical tool does it, because those exist. And if you're coming from Linux, same thing. Is there a command line tool to manage that on Windows? Of course there is, but most administrators are going to use the graphical tool, and here it is. And once you look at those graphical tools or see those commands, pretty much you're done. You've learned everything there is to learn. Sure, having a cheat sheet. Where do I find this tool for this task could be useful? That's not something to judge someone's capability on. Their ability to make decisions about products, their ability to design architectures, to protect your business, to think about your IT infrastructure, all those things are not affected. These are really, really minor points. You can't just throw someone who has used Linux into a Windows environment and expect them to not have to search around for the tools. Well, I'm not sure where to click for this. But you can't expect someone who used Windows 2012 to be able to work in 2022 in that way either. Everything's moved around. They have no particular advantage. In fact, in many cases, I would argue that someone coming from current Linux and moving to current Windows is in a better posture to manage that system than someone coming from a few versions older of Windows, simply because they're that little different under the hood. And that's with them not being a shared code base. Imagine if they were a shared code base moving between Ubuntu and Fedora Linux. You basically don't even notice. Like, we don't even talk about that as a thing to learn. But businesses will often confuse those things and think these are completely different skill sets, that knowing one doesn't mean you know another, because they think it's magic. And it just isn't. Learning the fundamentals. And this is really important across the board. If you're a business, make sure you're hiring based on the knowledge of the fundamentals. Everything else is cake after that. And if you're working in IT and you're wondering, how am I going to get into IT? How am I going to excel in IT? How am I going to keep up? Learn the basics. If you understand how networking works, it doesn't matter which networking protocol you're working with. All of the major ones that ever made it anywhere worked pretty much the same. Moving between IPX, SPX, TCP IP4, TCP IP6, there's some differences. They take an hour to learn the differences between. The fundamentals never changed. We always had routers, we always had switches, we always had access points. These things are shared, right? So learn those basics. Learn how operating systems work. Learn how storage works. Learn how software is written. Learn how binaries work in scripting languages. Get past those fundamentals and everything else becomes readily apparent. Instead of needing a vendor to explain how things are done, you can generally just look at things and say, oh, this is so obvious. This is what they're doing. And it makes everything so much easier because you don't have to memorize. If you're memorizing all of the pieces, you're memorizing the commands, memorizing the location of the GUI components, you're not going to be able to move between environments. You're not going to be able to carry on a discussion about those things. You're stuck in memorization mode. You may be able to carry out a task that you've done many times before, but that's where you're going to be limited to. You're not going to be able to move on to another thing. And if you're able to memorize a repeatable task, that task could be automated and your job could be replaced. But if you understand the fundamentals, you will find everything else in the industry to be much easier, and you will find that you're able to deliver a value that cannot be replicated in an automated sense because you're able to actually learn new things and constantly up to date. And keeping up won't be this big challenge. Still take work. You still gotta actively pay attention to what's going on in the industry, and you have to know which things are major trends. Ransomware is a great example. A number of years ago, we didn't have to worry about people getting on and using encryption tools to screw us over on our own computers. Encryption was something to protect us, not to hurt us. We'll have another video about that. But the idea that someone figured out they could use a tool that was already hurting us on accident and instead use it to hurt us on purpose was not necessarily something a lot of people saw coming. But once it was in place, it was really obvious that a simple technology that had always been there, it was used in a way it was already being used accidentally. No one was completely surprised by it who knew anything about encryption or computers. That it became a really big thing in the industry and became the number one thing that we're worried about in most cases. Yeah, that's a market trend that's a bit surprising, just like, wow, the Intel 32-bit processor family became way more popular than we would have guessed. Sure, we don't always predict which vendor or paradigm or protocol or technology is going to rise to the top and be the number one thing we talk about or think about. But that those things exist, that those possibilities exist, how they work, how to defend against them, those are things we've known all along. None of that is new. None of that is surprising. Those are things we should have been learning as fundamentals really in elementary and high school. Universities should be assuming those things are already known and building on them and helping people think critical about them. I understand that people are not doing that, but those resources are out there and people at those ages could be being introduced to those things and easily have those foundations so that we're moving to a whole new level of IT up above. For this to work requires two things. It requires you, the IT professional, learn the fundamentals. Don't look at things as magic black boxes and try to figure out how to use them without understanding what they do. Always understand what they do. Nothing is a magic black box. Doesn't matter if it's virtualization or some vendor product or storage or a GPU. It doesn't matter. All of those things are relatively simple to understand. If it feels like magic, stop, figure out what it's actually doing. Ask questions. Come on here if you need. Absolutely. If you need a video that explains how something works, I would love to do that. I just don't know what people need. Feel free to ask. That would be wonderful. If you are a company, stop approaching things as if your staff needs to memorize lots of different things because you will, one, pressure them to memorize instead of learning. You won't reward the actual work that goes into the things that actually matter. And two, you will start hiring really, really badly because you will start hiring someone who memorized the answers to your specific interview test that are able to get in and possibly only know how to do one job and can't answer questions about it, right? It is actually easier for a lot of employees looking for jobs in a lot of companies to memorize a bunch of useless answers that are not even things you should probably do in most cases, go into an interview and simply answer common interview questions with no understanding, no ability to add value to the organization. All that could have been automated. All that could have been outsourced for nothing, almost. And instead you hire someone who's not going to add value when instead you could have just had a good conversation, found someone who's interested and cares and has an aptitude, and all of the specifics you need, they could have learned in an afternoon or maybe a week, putting in some effort. And then they would have been up to date and way more valuable to you right away and valuable for you for forever. But instead, most companies are hiring someone who can do one task poorly, and they don't really even evaluate that task because they're not sure how, and it becomes an ongoing thing. Thanks for joining me. Please remember to like and subscribe. Ask lots of questions below. And remember, I have written a book, Linux Administration Best Practices, by Pact Publishing. It would be awesome if you wanted to support me by going and checking them out on Amazon. The book is something that I put a lot of work into and means a lot to me. And if you're looking for a greater depth of information on any of these things, if you need help in hiring, in education for your IT teams, if your IT team needs assistance in simply looking at problems, I work for ntg.co. We are a global technology consultancy. This is exactly the stuff that we do. I often get asked, is there a way that we can engage you outside of YouTube? And absolutely, that is what I have been doing for the last quarter century. Absolutely reach out. We would love to talk to you about how we can assist your department. I'll see you next time.